The final piece to the data collection and analysis unit is variability with mean absolute deviation. Let's remember that variation describes how the data spread out and that there's 3 ways we can calculate it: range, interquartile range, and mean absolute deviation. We've learned about range, we've learned about interquartile range, and now we're going to learn about mean absolute deviation. Mean absolute deviation is the average or the mean of the differences between each data point and the mean of the entire data set. As if that's not confusing enough, the name somewhat gives away the order that you're going to do things. First, you're going to calculate the mean or the average of the data set. So you go about calculating normal mean or normal average the way we have been all along. Now we find the absolute difference of the mean with each value in the data set. So we take the larger number minus the smallest number, absolute value, which is why it's called the absolute difference. Then we calculate the mean again of all the differences. So this is the one that's the biggest pain to do, is the most time consuming to do, because you're calculating mean twice for each problem. Starting off, the maximum speed in miles per hour of 8 roller coasters at an amusement park is listed below. I got this problem out of a textbook. You know, those things that are collecting dust on the bookshelves. I do not know what amusement park this is, do not ask me. We are asked to find the mean absolute deviation for the data and describe what it means. So first we're asked to just calculate what the mean is. So we add up all those numbers and we find out that the sum of the speeds is 512. There are 8 roller coasters. This means the average speed is 64. Next, we're going to go through each data point and we're going to subtract that number with 64 or from 64. So we're going to first subtract 64 and 58, which is 6. And now we're going to subtract 88 and 64, which is 24. Notice that for the first one, 58 was smaller than the mean, so 58 went second, or 64 went first. And with 88, 64 is smaller than 88. 88 is larger than the mean, so 88 went first. In both cases, it's absolute value, so we want the larger number first. Then we do 64 minus 40, which is also 24, but in the other direction. And we have 64 minus 60, which is 4. Now we move on to 72, so we do 72 minus 64, and that's 8. 66 minus 64, which equals 2. 80 minus 64, which is 16. And 64 minus 48, which is also 16, but in the other direction. Now we have to calculate the mean absolute deviation. So we're going to find the average of all of our differences. 6 plus 24 plus 24 plus 4 plus 8 plus 2 plus 16 plus 16 ends up being 100. There were 8 differences, so we divide by 8, and that's going to give us 12.5. So our mean absolute deviation is 12.5. This is variation because it's not talking about the center of the data. The majority of the data points are not around the value of 12.5. The majority of the data points are around 64. However, in theory, we can say that the data points are all about 12.5 away from the mean. So when it asks what it represents, we can say something to the effect of the MAD of 12.5 is smaller, but could indicate an outlier. And the reason it could indicate an outlier is if you want low variation, you want the MAD to be closer to 0. 12.5 is starting to get a little bit bigger, and that's why it may indicate an outlier. And when we look at it, there really isn't one other than maybe 40. But again, you have 48, but then there's a little gap to 58. And if you look at the other end, there's 88, and there's a little gap to 80, and then to 72. So the data isn't really totally consistent, and that's why it has the higher mean absolute deviation.